What happens when machines don't just see, but feel, taste, and create? Are we teaching them to understand reality or to replace it entirely? Artificial intelligence just blew through another barrier, and this time, it's getting disturbingly human. We're not talking about smarter chatbots or better recommendations. We're talking about AI that can simulate the molecular structure of matter, turn your photo memories into emotionally charged video stories, and even taste flavors like your tongue. Yes, taste with chemical precision. And that's not all. Meta is building AI-powered supercomputers so massive they need as much energy as a small city. DeepMind is creating software that speaks before you even finish typing. And researchers? They just built an artificial tongue that can tell sweet from bitter even when it's never tasted it before. This isn't just progress, it's acceleration. And it's starting to blur the lines between science, art, biology, and machine. So let's break it down, piece by piece, because if you want to understand the future that's arriving at warp speed, this is where you start. By the way, if your coffee machine starts giving you life advice, maybe just nod politely and walk away. Back to the story. Segment 1. Google Photos. AI turns snapshots into videos. Let's start with something that'll hit close to home, your camera roll. Google Photos is quietly rolling out a game-changing update, and most people haven't even noticed. Soon, your photos won't just sit around gathering digital dust. They'll be automatically turned into cinematic, emotionally animated videos by AI. That's right, your vacation pics, birthday shots, or random food snaps. They'll get stitched into full-fledged stories with music, with motion, with mood. This new feature is being tested in version 7.36 of Google Photos on Android. They've created a brand new full-screen creation hub. Think of it like unlocking a hidden cheat menu in an old-school video game. Everything you used to dig around for, animations, collages, fake 3D parallax effects, is now just one tap away. But the real magic? It's what's coming next. Behind the scenes, Google is testing two powerful new tools, Photo to Video and Remix. These aren't just templates. They use AI image models to reinterpret your media. One feature lets the AI generate entire video sequences based on your static photos. Another can remix your shots and clips into a new emotional tone, almost like an editor with a cinematic eye. Suddenly, your photos don't just remember a moment, they re-experience it. Now don't get too excited just yet. The album builder is oddly still missing, and full rollout timelines are fuzzy. But internal code flags suggest it's just weeks away, not months. And one tiny warning, AI video generation doesn't play nice with limited storage. If your phone already wheezes when opening TikTok, this might light a fire under it. But think about what this means. We're entering a world where AI won't just store your memories, it will reinterpret them, maybe even reshape them. Is that exciting or unsettling? Either way, it's coming. Segment 2. DeepMind. GenAI processors for real-time AI. Now let's shift gears from the personal to the powerful. Because over in the developer labs, Google DeepMind just unleashed something quietly revolutionary, a new software toolkit that might redefine how AI thinks in real time. It's called GenAI processors, and while the name sounds technical, the impact? Massive. The idea is this: every piece of data, text, sound, photos, even complex code, gets packaged into what DeepMind calls a processor part. These parts move down a pipeline, like cars on an assembly line. But here's the trick. Every station on that line starts working the moment the first piece arrives. That means the AI can start replying before you're even done typing. It's called faster time to first token. And it makes chatbots feel less like software and more like a conversation. This toolkit plugs right into Google's Gemini models, and it supports both the standard Q&A interface and the new Gemini Live feed, which answers in real time. And they didn't stop there. To help developers get started, DeepMind bundled in demos. One turns raw sports stats into live play-by-play commentary. Another pulls real-time info from the web and summarizes it on the fly. And a third listens through your mic and talks back. Yes, like a voice assistant, but smarter, faster, and trained on everything. This isn't just another software library. It's a framework for live thought. Competing libraries like LangChain or NVIDIA's NeMo exist, sure, but most were designed around slower one-way tasks. GenAI Processors was born for real-time back and forth. And developers are jumping in fast. The community folder is already filling with add-ons like content filters, document parsers, and even PDF splitters. The future of AI isn't just in what it says, it's in how fast it learns to say it. And DeepMind just gave that future an express lane. Segment 3. Meta's atomic-level AI chemistry model. From fast responses to fundamental science, Meta's FAIR Lab just dropped a breakthrough so futuristic, it sounds more like science fiction than software. An AI that can simulate atomic interactions faster than traditional physics. It's called YUMA, Universal Models for Atoms. And here's why it matters. Right now, scientists use a method called density functional theory, DFT, to simulate how atoms behave. It's accurate, but brutally slow. You can wait hours, even days, for complex models. YUMA changes that. It uses deep learning fed with over 500 million atomic structures to predict atomic behavior almost as precisely as DFT, but in a fraction of the time. It's based on something called an equivariant energy network, tuned with inputs like electric charge, magnetic spin, and more. First, the AI learns how atoms interact. Then, it gets fine-tuned to obey the laws of energy conservation, so it doesn't just guess, it respects physics. In real tests, even the smallest public version can simulate 1,000 atoms at 16 steps per second on a single 80 gigabytes GPU. And it still works on huge test cases with over 100,000 atoms. Meta even tested how performance scales. The more you feed it, the smarter it gets. And by using multiple expert networks inside the model, they cut errors dramatically without adding too much weight. Yes, it still struggles with edge cases, like interactions beyond 6 angstroms, but that's just the next frontier. What's the big picture here? AI is learning to simulate chemistry itself. Faster drug development, better materials, even self-replicating nanomachines one day. This kind of model lays the groundwork. And the fact that Meta's already publishing benchmarks and open sourcing its findings, that means everyone from researchers to rogue tinkerers can start building on top of it. The periodic table just got a neural upgrade. All right, brace yourself, because this one's both amazing and slightly creepy. Researchers have developed what they're calling a graphene-based artificial tongue. And it doesn't just pretend to taste, it actually senses flavor patterns with accuracy rivaling your own mouth. Here's how it works. They layer graphene oxide sheets just 1 atom thick inside a tiny channel that liquid flows through. As molecules pass by, they bump into the graphene, slightly tweaking its electrical conductivity. Those shifts create a signature, kind of like pressing a piano key and listening to its note. To teach it what those signals mean, researchers ran over 500 million reference chemicals through the device, including complex mixtures like coffee and cola. Then, they fed that data into a machine learning model. Result? About 98.5% accuracy on flavors it had seen before, and 75 to 90% on completely new ones. But here's the kicker. The sensor and processor live on the same chip. No shuffling data to external systems, no lag. That solves one of the biggest problems with old-school e-tongues, which often choked on the delay between detection and decision. Right now, it's still a lab prototype. It's bulky, power-hungry, and definitely not ready for your kitchen. But if engineers manage to shrink it, game on. Imagine this tech in medical screening. checking taste recovery after illness or stroke, food safety, spotting spoilage before your nose does, cooking robots, adjusting seasoning on the fly, just like a chef. Let that sink in. We're teaching machines to taste, not just detect chemicals, but interpret flavor. It's not just artificial intelligence anymore, it's artificial sensation. Segment 5. Meta's AI supercomputers, power plants for intelligence. Now, we've seen how AI is learning to perceive the world, but what happens when you give that AI more power than most countries? Meta is building AI data centers the size of power plants.
Mark Zuckerberg announced that their new AI supercluster, codenamed Prometheus, will light up by 2026 with over 1 gigawatt of energy capacity. That's enough to power nearly 750,000 homes. And it doesn't stop there. The Hyperion cluster could scale to 5 gigawatts over time, all of it dedicated to running massive GPU arrays. Zuck isn't shy about the mission. He says Meta is prepared to burn hundreds of billions of dollars chasing superintelligence. Capital spending for 2025 alone estimated between $64 and $72 billion. They're not just throwing money around. They're recruiting top-tier AI minds with rumored offers like $200 million compensation packages. That includes former GitHub CEO Nat Friedman and Xscale AI chief Alexandra Wang. So why the mad rush? Insiders say Meta's LAMA 4 model slipped because earlier models didn't improve fast enough. These superclusters, they're the fix. And the market doesn't seem worried. Meta stock is up, closing near $721 recently. Investors see the play. But here's the cliffhanger. If AI can already taste, simulate atoms, and turn memories into stories, what's next? Are we heading toward a world where AI doesn't just help us live, but starts deciding how we live? Let me know what you think in the comments. Hit like, subscribe for more breakdowns like this, and, as always, thanks for watching.